This is AQA GCSE Chemistry. It is the trilogy paper. It's the 2H trilogy paper from 2018, and this is question 5. Whole question is going to be shown to begin. You can pause as you go and try it for yourself and then review. So here's 5.1, 5.2, 5.3, 5.4, 5.5 and 5.6, 5.7, 5.8, and finally 5.9. And there are 17 marks available on this question. So let's go back to 5.1. A student investigating the size of marble chips on rate of reaction. Added 10 grams of marble chips into the flask, added 50 cm cubed of hydrochloric acid, connected the gas syringe, started the timer, and recorded the volume of gas produced every 10 seconds. The first question here is to complete the equation for the reaction. So calcium carbonate and hydrochloric acid. We need to know what products are going to be made, and a metal carbonate and an acid will always make a salt. Now, the salt, we get the metal from the metal carbonate, that's calcium. Hydrochloric will always make a chloride. Beyond that, you've then got to remember that calcium is in group 2, its ions have a charge of +2, and chlorine is in group 7, its ions have a charge of -1. So I need 2 chlorides to balance the 1 calcium, so CaCl2. You then need to remember that a metal carbonate and an acid makes a salt, and carbon dioxide and water. And all that's left to do then is balance. And I've got 1 Cl, 2 Cls, so let's balance them. I've now got 2 H's, but I've actually just balanced the H's as well. On to 5.2, describe the trend shown in figure 6 and use values in your answer. This is really important, using the values. So, the volume of gas increased by 36 centimetres cubed in the first 10 seconds. I've read that directly from the graph. In the following 10 seconds, from 10 to 20, it only went up by another 18. It went up by half the amount. Now, that's a more extensive way of talking about the general trend that the rate of reaction decreases over time. The volume of gas decreases over time. But because the question asked for values, we've gone into that level of detail. Finally, we can talk about the fact that the reaction stopped at around 29 seconds. No more gas was produced. And we've got 3 separate marking points, 3 marks. On to 5.3, describe how you would use figure 5 to find the rate of reaction at 15 seconds. You do not need a calculation. Well, we're going to take a look at the graph again, because at 15 seconds, how are we going to work out the rate there? Well, what we do is we draw a tangent to the curve at 15 seconds. And once you've drawn the tangent, something that will only touch the line at that one point, we can calculate its gradient. On to 5.4, give the units for the rate of reaction in this experiment. So we have got gradient is changing y over changing x. I've got cm cubed divided by seconds, so it's cm cubed per second. On to 5.5, give one conclusion about the size of the marble chips effect on the rate of reaction. You'll notice the rate increases as chip size increases. Is that right? There's a little bit of a common error at play there. We are being asked about the size of marble chips. Now, as marble chips get smaller, their surface area increases. So rate increases with an increased surface area. So the rate increases as the chip size decreases, because that is what the question asked. And then, on to 5.6, suggest why all 3 sizes of marble chips produce a maximum volume of 60 centimetre cubed of gas. And that's because we've clearly got a limiting reagent. The same amount of acid was used each time. 5.7, we've got 8 small cubes. They're 1 centimetre by 1 centimetre by 1 centimetre, and we put all of those together to make one large cube, 2 centimetre by 2 centimetre by 2 centimetre. What's the surface area of the large cube? Well, let's start by working out the area of one of the surfaces. It's 2 by 2, which is 4 centimetres squared. But a cube has 6 sides, each with 4 centimetres squared, so multiply that by 6 and we get 24 centimetres squared. 5.8, explain why the size of the marble chip affects the rate of reaction, and give your answer in terms of collision theory. And it ties in with what I spoke about earlier on the confusion of an earlier part of the question. Smaller chips have a larger surface area. If there's a larger surface area, it means there will be more frequent collisions. That will mean more frequent successful collisions, which means a faster rate of reaction. And finally, on to 5.9, the student repeated the investigation with small marble chips using hydrochloric acid with a lower concentration. Explain why the results for the lower concentration of acid are different from the results for the higher concentration of acid. Well, the lower concentration stops at 50 cm cubed rather than 60. It's also shallower. The gradient is less steep. And that's because there are less frequent collisions. There are less frequent collisions because there are fewer particles in the same volume. So that's going to bring the rate of reaction down. It's going to bring down the rate at which gas is produced down. And that takes us to the end of question 5.